I can't resist just a little more of a plausibility argument before we go on and do a rigorous proof. Here are the two dominoes, and when they're at this angle right here, the entire area, surface area of this domino projects down into the XY plane on the shaded area we see here, so that the ratio of areas is about 2 to 1. Now, according to the argument we've given here, that means that the secant of gamma would be about 2, and that's about how we've sketched it here. Now, if we change the orientation of the lower domino, we have a region that I can sort of sketch here. At least I can sketch the boundaries. And the orientation of this region is in whatever direction we wish here. If I look at these dominoes from this direction, they look just like this. They look like they're both in a plane parallel to the plane of my line of sight. And we can see the angle gamma between here and here. When I orient the dominoes as such, if I still have my X direction, let's say here, my Y direction here, then the direction in which Y changes most rapidly is just the direction along the long axis of this domino here, and that's of course, and let me rephrase that, I rise most rapidly if I climb straight up this domino. That's in this direction, and that corresponds to motion in the XY plane in this direction, so that when I move in this direction in my XY plane, I have a maximum increase in my value of F. The direction of maximum increase is just the direction of my gradient vector. So that if this domino here lies along the surface of some function f of xy, or approximates the surface on a small interval of some function f of xy, then this is the direction of the gradient. And that's fxi plus fyj. Now we see the connection between the gradient and the normal vector here. You might think about just what are the details of that connection. But now, what is the direction from which we view this pair of dominoes in order for the planes of the dominoes to be parallel to our line of sight? Well, that's from the direction perpendicular to the gradient. So we view from here. Let's say we view from this direction to, and I've got my X labeled here, I'm going to write over it to see the angle gamma. This direction perpendicular to the gradient.